Many physical quantities, such as speed, can be completely described by a single real number called a scalar. This number indicates the magnitude or size of the quantity. A vector is a quantity that has both magnitude and direction. The length of the line segment represents the magnitude of the vector. The direction of the vector is the directed angle between the positive x-axis and the vector. Formula for magnitude. The sum of two or more vectors is called the resultant of the vectors. The resultant can be found several different ways. The first method we are going to look at is called tip to tail method. For each given pair of vectors A and B, draw the vectors A plus B and A minus B. So you start by placing any vector with its tail at the origin. Vector A is placed with the tail at the origin. The tail is the initial point or the starting point. Then number 2, place the tail of an unused vector to the tip of the previous vector. Vector B, we want to keep vector B going in the same direction with the same length, same magnitude. So you can look at vector B as counting the slope of the line. So from start to end, the initial point to the terminal point of B, you rise 1 and you run 1, 2, 3, 4. So you come to the terminal point of A, and I'm going to rise 1 and run 4. 1, 2, 3, 4. So I add B here. Therefore, for A plus B, I start at the beginning of A and it goes to the end, the terminal point of B. So this represents A plus B. For A minus B, you want to go to the terminal point of A, but this time for B, you want to go the opposite direction. So I'm not going to rise 1, I'm going to fall 1 and go to the left 4. 1, 2, 3, 4. Again, start at the initial point of A and go to the terminal point of B for A minus B. So, for the next example, we have B, rise 1, 2, run 1, 2, 3, 4, and 5. So let's first do A plus B. Rise 2, run 5. A plus B is from the beginning of A to the end of B. A plus B. A minus B, I'm going to fall down 2 and go to the left 5. So again, start at the beginning of A and at the end of B. A minus B. Vectors have the vertical and horizontal components. And when we say vertical and horizontal components, it's just the x and the y value. To find those, we know from the unit circle with our coordinates that the x represents the cosine and the y represents the sine. So we actually have formulas to find the x component. We have the magnitude, which is r, times the cosine of your angle, your directed angle. So the x component would be 40 cosine of 330 degrees. You look on your unit circle and get the cosine of 330 degrees, which is radical 3 over 2. multiply. We have 20 radical 3 for our x component. For our y component, we use sine. So the magnitude times the sine of our directed angle, 330. Refer to the unit circle to get the sine of 330, which is negative 1/2. So our y component is negative 20. So the component form is just your ordered pair, your x and your y. 20 radical 3 and negative 20. Find the magnitude and direction when you have the component form. Again, the component form is your ordered pair, your x and y. So we are going to go in reverse and find the magnitude and direction angle. We have the formula at the top of the paper to find the magnitude, which is square root of x squared plus y squared. My x component is negative 2 squared. My y component is negative 5. That gives me radical 29. Cannot break down 29, so it remains under the radical. For the direction angle, we have our sine value, we have our cosine value, and we know that tangent of theta is sine, which is negative 5, over the cosine, negative 2. I'm looking for the angle, so that means I will end up doing the inverse of tangent and enter the inverse of tangent of negative 5 divided by negative 2 in my calculator, and yes, you get a negative angle. But keep in mind that direction is never negative. So if you get your direction is a negative answer, you take the absolute value. So the direction angle is 68.2 degrees. We're not done. Go back to the definition. The direction of the vector is the directed angle between the positive x-axis and the vector. So we need to go back and visit that. Visualize. Here is the positive x-axis. This vector is located in quadrant 3. Negative x and a negative y ends up in quadrant 3. So my direction angle is from the positive x-axis all the way to my vector. Well, we already calculated that this theta is 68.2 degrees. So I must add 180 degrees to that to get my direction angle. So I have 180 plus 68.2 degrees, which gives me 248.2 degrees for my direction angle. Magnitude, radical 29, direction angle, 248.2 degrees. Okay, when we are working with vectors in component form, the operations for adding and subtracting or dot product, which is the multiplying, is very easy. You have the rules here in your text box. So let's look at some examples. Vector W is given and vector Z is given. Perform the indicated operations. So W minus Z is very simple. We subtract the two vectors. Vector W minus vector Z. Follow the rules here in your text box. So you subtract your two x's. So negative 3 minus 5 yields negative 8. Then you subtract your two y's, y1 minus your y2. multiplication, it's like the distributive property. You multiply the negative 8 by everything in the inside of your brackets. Okay, we have 3 times vector w plus 4 times vector z. Follow order of operations. So 3 times vector w plus 4 times vector z. Of course, we multiply first. 3 times vector w gives us negative 9, 6, plus 4 times vector z gives us 20 and negative 4. Now we add our two x's together and the two y's together. This multiplication is called dot product. Make sure you look at the rules. You're multiplying your two x variables, x of 1 and x of 2, and you add it with the product of your two y's. So w dot product of z. Again, I multiply my two x's, negative 3 times 5. Add it to the product of my two y's. Very simple. Alright, it is sometimes important to find the angle between two vectors because sometimes we need to know if vectors are parallel or if they're perpendicular. So, there is a theorem called the dot product theorem to help us find the angle between two vectors. The theorem is here. So I'm going to summarize these notes. If you calculate your dot product theorem and you end up with 0, that means the angle between the two vectors is 90 degrees and the two vectors are perpendicular. If you calculate your dot product theorem and you end up with positive 1 or negative 1, that means the angle between the two vectors are 0 or 180 degrees, and the two vectors are parallel. Otherwise, it would be neither. The vectors are not parallel or perpendicular. Let's look at an example. So, before I start the example, I need to point out something. Keep in mind that this means dot product. And in your denominator, this is the magnitude of your two vectors. Alright, so we're going to find the angle between vectors A and B, vector A and vector B. So we have cosine of theta, or alpha, or whatever letter you want to use. We do the dot product in the numerator, so I multiply my two x's, add it to my two y's. In the denominator, I find the magnitude of each vector. So for vector A, it'll be the square root of negative 3 squared plus 2 squared times vector B, 4 squared plus 5 squared. And I simplify. This gives me radical 13 times radical 41. So I have negative 2 over radical 533. Since we're going to enter this into our calculator, don't worry about rationalizing. Save yourself some time and just input it. So theta, again, I'll have to do the inverse since I'm looking for an angle. The inverse of cosine, negative 2 divided by radical 533. And that gives me 94.970 degrees. So that's the angle between the two vectors, and that gives me that the vectors are not parallel or perpendicular, so that gives me neither.